Hello everyone. So today we will discuss about application of thermodynamics. First law. So before this, we will take a small description of what basically is first law of thermodynamics. So first law of thermodynamics tells about, and it is nothing but the restatement of principle of conservation of energy, that is in terms of heat energy, and it states that overall change in the internal energy and the work done, that is on the system or by the system, is the sum, total sum will be always same, will not be changing. So in short we can say that when some quantity of heat is done, or it is supplied to the system, according to this we can say by first law of thermodynamics, we can say the change in heat supplied to the system that is capable of doing some work, let that quantity of work and the quantity of energy of the system. So this is equals to change in internal energy of the system, and due to which the rise in temperature does some work. So this will be equal to dW, or we can write this as delta Q is equals to delta U plus delta W. So this is your first law of equation, first law of thermodynamics. So we have talked on this, that whatever heat is given or supplied to the system, the internal energy and work done is will be changing accordingly. So you need to consider the system. Let this be a piston, and let this be the volume. So whenever heat is supplied to the body, to the container, so internal energy of the system changes, which pushes this piston, and due to this the piston is displaced by some value. So we can say the work is done by the system, means there is some internal energy change, and also with the change there is some work done by the system. So this overall heat, that whatever heat is given, that is basically converting into the internal energy and work done by the system. So this is nothing but the first law of thermodynamics. So what do we understand with this? So what are the application? First application is in isothermal process. So what is this isothermal process? Iso means same temperature. So in order to maintain the same temperature to be kept constant. And when temperature is kept constant, so what will happen? The overall internal energy will be also remaining same. This means U is also constant. So when heat is not, means heat is maintained throughout the time, the overall internal energy will be remaining same. So that means there is no change in internal energy. So we can say that in this equation, delta Q is equals to delta U plus delta W. This will be 0, means delta Q is equals to delta W. Means whatever heat is given, all that heat is directly being converted into the work done. Means there is no net change in the internal energy, but all the heat given will be supplied directly to the piston, which displaces it by some value. Clear? Means we can say that heat, whatever heat is supplied, is used to do work against the surrounding. So this is what is the first application of thermodynamics, first application of the first law of thermodynamics, we must say. Now second, this was the isothermal process. Now let us consider about this adiabatic process. What is this adiabatic process and how does it is being an application for this first law of thermodynamics? See, in adiabatic process, the whole system is insulated. We can say there is no transfer of heat from or to the system. So we can say no heat energy transfer. Since the walls of the container or the system is perfectly non-conducting. So in such case, whatever heat is generated inside the system, that is not coming out, or whatever heat is generated outside the system, that is not coming in. So we can say in this process, no heat energy uh, gets, we may say, enter or leave the system. So whatever heat is there, there is no exchange whether it is whether it is to be coming out or entering in. So there is no such heat energy that is being exchanged between the surrounding and the system. So by this we can say that overall heat remains same. So there would be no change in heat, and if there is no change in heat, the change in heat could be shown as 0. Means delta Q is equals to delta U plus delta W, and this becomes 0. Means delta U plus delta W is equals to 0. Means delta U is equals to minus delta W. So what does this tells you? That when there is any kind of change, let us suppose that in this system, the piston is directly pushed or the system is directly pulled up. Overall heat that is generated will be nothing but the change of the work done. Means this work is done. Suppose it is compressed, it is pushed down. This piston is pushed down. What happens? Overall, when the work is done against this well system, this will decrease the internal energy. Means whatever change is done in the internal energy, the overall change in internal energy will be in negative terms. Let us suppose in a different manner. Let us, if this is pulled upside, what happens? When this is pulled upside, the temperature inside the system gradually falls, means the temperature becomes less down, and the gas will be cooled, whatever fluid is filled inside this. And if it is suddenly compressed, the overall energy is heated up. You can consider an example of such case to be a kind, what means it will not perfectly satisfy, but it may be satisfy as an example. Means you can take it as an example. So how would you take it as an example? Nothing but the cycle pump. So as soon as you pump the air into the tube of the cycle or whatever it is, a vehicle, the sudden pressure increase will make the piston, make the pump to heat up. Simple. Okay, now let's talk about third application, that is isovolumic process. So what is this isovolumic process? Iso means same, volumic means volume. So in this case, the volume is kept constant, means dV is 0 since V is constant. V means volume. So if let us say that W is equals to F into ds. And what is F? F is equals to ma into ds. And what is a? Okay, and acceleration is a is acceleration. So let this be. And similarly, uh, power is equals to pressure is equals to force upon area. Multiplying and dividing it by L, we will come to F into L upon area into L. F into L means the length or the distance. So it could be considered as distance, and A into L means volume. So pressure is equals to F into D by V. So PV is equals to F into D, and F into D is nothing but work done. So we can write this as W is equals to PV also. So putting this equation in mind, since dV is equals to 0, we can write this as uh, this to be dW. Since work done is less, let us consider for the differential condition. So dW is equals to P dV. Okay, since dV is equals to 0, this complete becomes 0. And if this dW becomes 0, then delta Q is equals to delta U plus delta W. That means delta Q is equals to delta U is, or whatever heat is given, that is only and only getting converted into the internal energy, and nothing extra work is done by the system to push or pull the piston. Means you can say the heat energy is completely converted to internal energy. Okay, so this is what basic applications of first law of equation was, first law of thermodynamics. Now let us talk about some other topics also. So after this, fourth application which we will discuss is cyclic process. This is very important. Cyclic process. So what is this cyclic process? Cyclic means that process after certain time, or which can be recycled, we can say that if there we start from some point and the process is continued in such a way that it comes to an end where it got started. So such a kind of process is known as cyclic process. So it must be known as initial state and final state. So cyclic process is non-cyclic process or normal process are nothing but from initial state they come to the final state. But if anyhow when a final state can also be returned back to the initial state, then such kind of process is known as in cyclic process. So since initial state is continued means whatever where there is the change. So in this case, U is the internal energy is kept to be constant. Since the process could come on its initial state means that is that whatever with the internal energy at the initial state that was again regained. So in such case, du is equals to 0. And if this happens means delta Q is equals to delta W. So you can see in isothermal process also we got the same equation, and in this cyclic process also. What does this means? This means that net work done during a cyclic process must be exactly equal to the amount of heat energy generated. We can say not generated, it is basically it is getting transferred. So whatever heat energy is being transferred from outside to inside through the walls of the system, so overall work is done in the cyclic process on whatever that is equal to the amount of heat whatever it is getting transferred. Now next application for the same would be melting process. So during melting process, as we have already talked about the melting process, in this case during melting and boiling process, during melting and boiling process the temperature remains same. That means during melting process the temperature will be remaining at 0 degree if we talk about water, and in boiling case the condition is that the temperature at that point of time will also be remaining same, and that the state would be at 100 degrees Celsius, and the energy associated with this, the heat that is associated with this is nothing but our own latent heat. So we can say that when solid melts into liquid, what happened? So internal energy increases. Why internal energy increases? Since the kinetic motion starts to get increased. Therefore, we could say that internal energy increases. Also, what happens? And by this, let us consider mass of the solid to be m and latent heat to be L. So, whatever be the amount of heat absorbed, that is only changing the state, and it is not utilized to increase the heat or the temperature of the substance or the system. So, we can say that overall change in heat is nothing but could be written as ml. Now, if there is a melting process, some small amount of volume is taken. Let us say that small volume is equals to dV. There is change in volume. Let it take. Now, also from this equation, small volume is dV. So P dV is equals to dW. Now, since there is very small volume that could be negligible, means dV is again equal to 0. Then dW would also be taken to be 0. Now, from first law, delta Q is equals to delta U plus delta W. Since delta W is 0, so we can write this as delta Q is equals to delta U. And what was delta Q? Delta Q is equals to ml. So, overall internal energy during the melting process increases by ml, we can say. Clear? Now, let us talk about the next, we can say, application of thermodynamics,